same order of accuracy. Okay, so the instruments which are calibrated directly, it will be named as an direct calibration. Whereas in the case of an indirect, the procedure is based on the equivalence of two different devices adopting some same similarity concept over here. Okay, so these are all about the sensor calibration. So the calibration is just a set of operations in order to establish the relationship between the values that are indicated by the measuring instrument and corresponding known value of an measurement. Okay, the next one will be the sensor output type. So we have three basic types of signals that will be considered as an sensor output. One to be the analog voltage, and second one to be the PWM, and third one to be the serial digital. Okay, so let me see one by one. So what about the analog voltage? Actually, the sensor output and analog voltage is proportional to some parameters which they are sensing over here. The diagram, typical analog transfer characteristics for a distant sensor is shown over there. What about the slope of the curve? Actually, the slope of the curve in the usable region is usually specified in the data sheet. Okay. Whereas the analog signals are much more susceptible to noise than digital signals. Okay. So there are several measures that must be taken to ensure the data. The most common techniques for noise reduction are will be using of an differential signal transmission and passive low-pass filtration. Since by using a microcontroller, so it may be convenient to apply an IAR filter or an SIR filter coded in software. So this is about an analog sensor transfer characteristic. What about in the case of an PWM? So actually PWM is a pulse width modulation. It is a popular technique for transmitting digital data in embedded systems. Okay, so actually it is shown below over here. So for a digital sensor, if you are considering an n-bit resolution, so the on time, that is T on, can take super n different values over here. Okay, and similarly, a change in one LSB1 is signified by a small change in the on time, usually specified in the data sheet in seconds per bit over here. And a PWM signal is much more immune to noise than an analog signal, but signal integrity can still benefit from differential transmission. And apart from that, it also a speed requirement. Any circuitry in between the sensor and the microcontroller must exhibit a short settling time to preserve fast signal. Okay. If the rise time of a PWM signal is too slow, it may not be possible to use overall. And the last type is to be the serial digital. Whereas the serial digital signals are to be the most complicated, and this type of signal requires that the devices sharing information are synced, and this is accomplished using one of many data packet protocols. Okay? So an example is shown below. Actually, this is the type of signal which is used for communication between the Arduino and the computer over an USB. Okay. So in order to communicate, the two devices must agree on the serial transmission protocol and the symbol rate to be an baud. So baud is to be the symbol rate. Okay. So being a digital signal, the noise margin is quite high, but the signal integrity is still substantially improved with differential transmission. So after PWM, any signal conditioning circuitry must be fast to preserve pricing and falling edges. So it is unlikely that we will be using this type of signals for communication from sensor to the microcontroller, since PWM and analog are so much simpler to use overall. Okay. So overall, in the first unit, we have seen about what is an instrument. It is a device for determining the value of a quantity or a magnitude of a quantity or an variable. And what about an errors over on it? Okay, so we know that three different types of errors: gross error, systematic error, and random error over here. Okay, then error analysis, we have seen about an arithmetic mean, average deviation. Okay, particularly when you are saying about an what about the purpose of measurement? So in order to monitor or in order to have a control, in order to collect data, or in order to validate the event. Okay? So the methods will have a direct method and indirect method. What about transducer? Actually, it converts converts one form of energy into electrical form of energy overall. Okay. Main classifications of a transducer will have active and passive. In the case of an passive, it does not require any external power supply. And similarly, in the case of an active transducer, actually it will work with the help of an external power. Okay. So here the example of passive transducer are to be the capacitive, inductive, and resistant. Whereas the case of an active, velocity, temperature, light can be transduced overall. Okay. Then apart from that, we have studied about an calibration. Okay. What about the static and dynamic characteristics? And then we'll be seeing about what about the calibration and the